Hello, I'm Nithish Barath from saitechinfo. Today, I'm going to explain about the sketch note that I have prepared for the lesson Electromagnetic Induction of class 12. First, we'll be moving to the Faraday's law, which explains if the magnetic field linked with the closed coil changes, then the EMF is induced in the circuit. That is, phi is equal to BA cos theta. SI unit is Weber, represented by WB.
So first of all, you tell what are the important subtopics. Okay, so identify, locate the subtopics. Okay, then you can proceed individually. So what are the total number of concepts? How many concepts are there in this EMI?
Today we are going to cover only four topics on
Four
the
concepts.
concepts
Okay, so the remaining will be discussed in the
in the part
part
two.
two. So you are going to focus on four important concepts. So what are those four important
The
concepts?
four important topics are Faraday's law, Lenz's law, motional EMF, and self-induction.
Okay, proceed.
So then the Lenz law states that it indicates the direction of the induced current. It can be represented diagrammatically. If a magnet is brought near a circular loop, then we can notice current induced in the circular loop will move anti-clockwise, so that we can remember it as N, which indicates the anti-clockwise direction. Similarly, when south pole is brought near a circular loop, then the direction of the current will be in clockwise, which can be represented as S, which indicates the clockwise direction. Then, in third case, when the magnets are in rest position, there will be no changes in this loop. So next, in Lenz's law, we will see the relative motion between the loop and magnet. In
So,
this,
what's the difference between Faraday's law and Lenz's law? Faraday's law states that phi b,
yes,
phi
sir.
b means magnetic flux,
Magnetic flux. Yes,
induced magnetic flux. That is equal to Ba cos theta.
BA cos.
But equation wise, what is this Lenz's law? What is his correction? He
That
indicates the
is
direction.
direction.
Okay.
Yes. Now we can consider three cases where the loop and the magnets are moving in a particular velocity. So in first case, we can take the velocity of the loop is greater than the velocity of magnetic field. In this, we can observe the loop is moving in a anti-clockwise direction due to greater velocity than the magnetic field. If two objects are moving if consider this is a loop and this is magnet, if this is moving in a greater velocity than this loop, magnetic field, we can observe that the direction, sir, can I
Direction of the loop.
direction of the loop is
Field.
changed due to the
You mean to say the relative change in the velocity,
yes, sir.
relative motion.
Yes, sir. Then in the second case, similarly, when the magnet is moved faster than the loop, there will be no change in the loop, because there will be no interaction between the magnet and the loop. In third case,
So the relative motion between the loop and magnet is very significant.
yes, sir.
Okay.
Then in third case, when the object, that is magnet and the loop, are moved in an opposite direction, first we will take when they are moving towards each other, we can observe when the north pole is brought near the that is circular coil, the direction of the current will be in anti-clockwise since they are brought together. In the opposite direction, we can notice there will be no change because there will be no interaction between the magnet and the loop.
You can interchange the position of the poles also. For example, you can introduce a north pole first, followed
Yes,
by
sir.
south pole. So you have to change that, is it not?
Yes, sir.
North pole, south pole interchange. First, north pole facing the loop, then
South
south
pole.
pole facing the loop. Okay.
Then
So
the
you
loop,
can,
then the
yeah,
current will be moving in a
exactly.
circular direction when the magnet is brought near this coil. Then we will move to the motional EMF, which states we can take an U-shaped coil connected with a copper wire.
The two arms of the coil is connected with the wire.
Yes, sir.
Okay, cross wire.
Yes, where the length is L and the breadth is X. Area of this particular region ABCD is L into X. We know that phi is equal to BA. So we are substituting the value of area which is equal to BLX. Considering this as a first equation, we will move upon to the EMF which is equal to d phi by dt.
Okay, very good. So here the main idea is, for example, let me consider the Faraday's magnetic induction. So in this case, this magnetic flux, induced flux is a response is due to the change in the magnetic field, the change in the area, the change in the rotation angles.
Angles.
Okay, angular that. So by changing the magnetic field, you can change the magnetic induction by changing the area enveloped by the coil. So this is the one you want to attack here.
Yes.
So here by adjusting the position of the
Area.
rod, you can change the area.
Area.
So that is a very idea.
Yes, sir.
So here we are rotating. So in case of any dynamos or motors, we are changing the theta value.
Yes, sir.
Rotating.
Yes,
Okay.
sir. Here we can see that the EMF is produced due to the motion of this C and D coil. So therefore, we are applying the value of phi in the E is equal to d phi by dt, which is equal to minus BL into dx by dt. Because BL is constant, they are not going to change, and x will be not in a constant value. Therefore,
That is a variable, dx
yes,
by dt.
dx by dt. We know that dx by dt, that is the rate.
That is how fast you change the position of this cross rod.
Yes.
Like that.
Yes,
movement.
sir. That is, we know that rate of change of displacement is equal to velocity.
Very good.
So
Very
we are writing this EMF, that is current induced, is equal to BLB. Similarly, the potential difference across the circuit is that is the coil is equal to BLB.
Very good.
Now we will be moving to the last topic, that is self-induction, where phi is directly proportional to the current. So we are taking the constant L, which is coefficient of self-induction. When we take this I to the denominator of phi, we will get L is equal to N phi by I. SI unit of this, okay, we will move to that, I'll say that last. E is equal to d phi by dt. We are substituting the value
E
of
is equal
phi.
to minus d phi by dt.
So here
அங்கே ப்ரீவியஸ் கொஷின் அங்கே மைனஸ் போட்டிருக்கே.
yes, sir. Here we are substituting the value of phi, which is equal to Li, and we will get E is equal to L, which is constant, into di by dt. So taking L, we are going to find the self-induction. Therefore, we are taking L is equal to minus I by di by dt. So this is the self-induction. Now in this, we are getting a case for a long solenoid, where N, that is
What is solenoid?
solenoid is a circular loop.
Circular loop arranged in a cylindrical manner.
Yes, sir. Now we are going to take.
So that is wound around the core, iron core like that.
Yes, sir. Now we know that N is equal to total number of turn per unit length. Therefore, N is equal to number of turn by length. But we know B, which is equal to mu naught Ni. Now to find the total.
What is mu naught?
So that is relative permeability of free space. Permeability.
Magnetic permeability. அங்கே வந்து ரிலேட்டிவ் கிடையாது. மேக்னெட்டிக் பர்மியபிலிட்டி த்ரூ வேக்யூம். ரிலேட்டிவ் பர்மியபிலிட்டினாக்கா மியூ ஆர்னு வரும்.
Okay.
ஸோ திஸ் இஸ் மியூ நாட் மீன்ஸ் த்ரூ வேக்யூம். மியூ மீன்ஸ் த்ரூ சர்டன் மீடியம். ரிலேட்டிவ் பர்மியபிலிட்டி மீன்ஸ் மியூ ஆர் அப்படின்னா மியூ ஆர். மியூ நாட் டிவைடட் பை மியூ. ஓகே.
Okay. So to find the total magnetic flux linked to the solenoid, which is equal to the flux of each turn into total number.
And that is
of
why
turns.
sometimes it is replaced. Mu is replaced by mu naught into mu r also.
Okay.
Mu you can mention here mu r is equal to mu divided by mu naught. Do you understand this?
Yes, sir. So we are taking phi is equal to BA, which is the flux linked to the
Magnetic flux.
magnetic flux into number of turns, that is N into L. So applying the first equation Applying first equation in the above reaction, that is the equation, we get phi is equal to mu naught I A into NL. Now we know n is the
Number of
number
turns.
of turn per unit length. So we will be taking n is equal to capital N divided by L in this
Capital N is total number of
total
turns.
number of turns. Yes, sir. So finally we will be getting phi is equal to mu n square I
Mu
by
naught N.
mu naught n square I A by L. So in case of self-induction, we know that phi value is Li from the above self-induction reaction equation. Now applying this, let us consider this as equation 3, and applying this equation 3 in this reaction, that is equation, you will be getting Li is equal to mu naught n square I by A into L divided by L.
So I can be cancelled.
I can be cancelled on both sides, and we will be getting L is equal to mu naught n square A by L.
Very good. So for solenoid, mutual induction is given by mu naught into n square
A by
into A divided by L. So capital N means total number of turns.
And
Small n means total number of turns for unit length. Okay, good. And what is A?
So area is the area of the
area enveloped by the coil. Okay. Then L, the length
L
of
is
the
equal to length of the solenoid.
solenoid. Okay. Very good.
This I will conclude this for part 1, and remaining mutual induction and AC generator we will see in the next part 2.
Okay. Very good.